they say find the z-score that corresponds to the area of 0.3632. Now, if you look in your book on page 252, they show you this, and where it comes together. This is the part where you're looking for this. In this whole mess of numbers, we find this number, and then we backtrack it out to the z-score. So when we backtrack out to your z-score is going to be this. I think this is the right z-score, right? I look at it right? Yeah. Okay. So now, it's the reverse. Before we gave you a z-score, you looked it up in your table, you gave me the area. This time we give you the area, you backtrack it out, and you look for the z-score. Now this could get pretty nerve-wracking because you have to look in all the little numbers. Sometimes the number isn't exactly there, so you got to figure out which one is it closer to, or maybe even it's halfway. God bless you. So instead, we have a little calculator one for this. So in your calculator, if you do second pairs, God bless you, number 3, inverse norm. This says, let's do the opposite of what you normally do. Let's take your area and find your z-score instead, the opposite. So second pairs, number 3, you're going to put your area in, 0.3632. You're going to leave it, because you're working with z-scores, you're going to leave it in a standard normal curve, 0 and 1. And then you're going to paste. And it's going to come back and give you a z-score. And all your z-scores get rounded to 2 decimal positions.
So what would you go for the area?
The area that they gave you, 0.3632. We're on the first one. We did it by your chart, now I'm doing it by your calculator.
So what would you put for the mean?
0 and 1, because you want to find the z-score. So right now, if we want to find the x value, then we'll put the mean and the standard deviation. But right now, we want to find the z-score. So we're going to leave it on your standard normal curve and just pull off your z-score. Then you're going to round it to 2 decimal positions. 0.35. Well, your calculator does a far more exact job than the table, but the table only can go to 2 decimals. So we're going to keep all of ours to 2 decimals and just make life simple. Okay, now, another way you might look this up is they give you a percent. They say find a z-score that has 10.75% of the distribution to the right of that number, to its right. So, on my normal curve, where would I find 10.75% to the right? On the left side or the right side of this graph? God bless you. On the right side. I want 10.75. I know this is 50%. So maybe somewhere over here to the right is 10.75% of my distribution. My area under the curve is 1 or 100%, right? This time it said this is the area to the right of this. I need to find my z-score that goes with this. Now, you have a couple of choices. You could use the fact that this is symmetric. You can bring this down to a decimal, just move your decimal over. You could use the fact that this is symmetric, and you can find this area and find this negative z-score. So look in your table, your big table, to see if you see 0.1075. It's not on theirs. You're going to have to look at your table. And you're going to tell me what your z-score is. Negative 1.24. Good. So therefore, if I'm looking for this guy with the same area to the right, what would my z-score be? 1.24. Okay, that's using your symmetry of your curve. Yeah, the negative is over here.
Oh, okay.
But I want this guy that has this amount to the right. So you told me it was going to be on the right-hand side of my graph, right? But we're doing this a couple of ways. We're using the concept of symmetry. I can find the negative and it would be the same as the positive. Or, let's look at it a different way. I could take the area to the left and I'd look up my regular z-score. So to find my area to my left, I have to say 1 minus 0.0175. And I have to look up this area. That's what they show you in the example. They looked up this area and they got 1.24. Does everybody see what we're doing here? Two different ways. One, we use the concept of symmetry. This area is the same as this area. Because they're equal distance away from my zero, if I get a negative, I know it's the positive on the other side. The second way is, area is always given to the left. So if I want to look that up in my table, I have to find the area to the left. So I subtract it from 1. I'm probably always going to ask you for the sketch. But isn't that helpful? Because, like, when Brandon looked at this, he said, well, isn't it negative 1.24? But Brandon was the first one to tell me that it was on the right-hand side. So doesn't that make sense? Like, well, it can't be negative. It will be positive. So the sketch itself is what really helps you. Now, here's a nice one to put in your calculator. Watch. I'm going to look up the area to the left. So watch what your calculator can do. I'm going to say 1 minus 0.1075. I'm going to let the calculator subtract this because I know I have to look up the area to the left. It's 1 minus that area to the right. And I'm just going to put it in and paste. And I get 1.24. Your calculator will do that for you. You don't have to do the subtract yourself. It makes a nice little spot too, because otherwise you get out of your calculator, do the subtraction. If you subtract wrong, you get the wrong area. Let the calculator worry about that. So remember, your table will look up areas to the left. Always area to the left. Okay? All right. You guys do this one. This one's slightly different. This one says, find me the z-score so that 95% of my curve sits between these two. So I don't know where they are, but it's a big chunk, isn't it? And wouldn't z have to be the same thing? So wouldn't this piece and this piece have to be the exact same? And wouldn't this piece and this piece have to be the exact same? Right? Yeah. So if 95% sits here in the middle, what's left over for these two ends? What's 100 minus 95? 5%. These two pieces have to add up to 5%. So 2.5. So if I took 5 and divided it by 2, this is 2.5, this is 2.5. If I said 95 with a decimal, and I said 0.05, and I divided by 2, 0.025, 0.025. This is a percent, this was a decimal. So what is it I need to look up? When I do my inverse norm, what number do I put in there for area? Not 0.5. 0.025. So now, if I pull up my calculator and I say, okay, inverse norm, number 3, give me 0.025, and then paste, I will get this answer, which is negative 1.96. Now, let's look at this for a second. Do you remember when we did the empirical rule? The empirical rule said plus or minus 1 standard deviation, 68%. Plus or minus 2 standard deviations, approximately 95%. Isn't that approximately 95%? Isn't it close to 2? Negative 1.96, positive 1.96. Isn't that almost like your plus or minus 2? Because these are just rounded. And your plus or minus 3 was 99.7%. Now, here's another little nice thing about your calculator. But you got to watch this part. Your calculator says, well, you know what? You did all your subtraction. Let me do your subtraction for you. So let me go back here to number 3 and say you wanted me to take 1 minus 0.95. We did 1 minus 0.95. Then we took that and we divided it in half. Divide by 2. Let your calculator do this. But you have to have those parentheses around there. Otherwise it's going to divide 0.95 divided by 2. So it's exactly what we said out loud, and there's your same answer.
So how would you put additive with the 0.2,
We just 0.025. I did that one first. Just put the 0.025 in there. It's essentially you're doing it by hand, right? Rather than let your calculator do it. You still have to tell it what to do. It's not that smart. It needs you to be smarter than it. Okay? So again, if I said 80%, 80% of my data lies between plus or minus z, and 80% is in here. What would my formula say for me to look this up? What would I look up? So how do I find this z? Okay, 100 minus 80, so these are 20% altogether. So I could divide it in half, 10, 10. So 0.10, 0.10. Or I could tell my calculator, and in your calculator you have to use 1. You can't use 100. 1 minus 0.80, then why don't you divide that in 2 for me? And I'll put that in my argument.
Whenever it says, whenever 80% and it says line between the decimal place and divide by 2.
Subtract it. Yeah, subtract it and then divide by 2. Okay? Now, another good use for this is percentiles. We talked about this back in chapter 2, back in unit 2. Percentiles. Percentile, this is your cumulative area from 0 to 100. So if I want the 5th percentile, that means I've moved out here 5% worth. This is 0.05. Find me the z-score for that. That's all this means. So I look in my table, or I look at my calculator, and I say, inverse norm. This is the one place that you'll really, really use your calculator for, because it just makes more sense. 0.05, don't I want my area to the left, right? Because I'm reading from left to right. There's my z-score. Negative 1.64.
55.
No, round to the 3rd decimal place.
Yeah,
I'm sorry, the 2nd decimal place. So 4 rounds up. We're going to find this one later is really 1.645 because it's exactly in the half, but 1.64 is fine for now. So where do I find 50%? In the middle. What's my z-score in the middle? 0. My z-score is 0. That's 50% of my curve. Where do I find 90% of my curve to the left? My 90th percentile. Way up here, right? Isn't this all 90%? So this is my 90th percentile. I am better than 90% of my field. So I'm just going to do inverse norm. And if you want, just do it this way. Take this and change this. Instead of 5, put in 10. I got 10%, I'm sorry, 9. 90%. 90% of my curve. And enter. And there's my z-score, 1.28. Your percentages read from left to right. It's your cumulative. That's why we use your normal CDF. That's your cumulative. Accumulate your area from left to right. Okay, you guys try it too. It's just easier if you start with your curve. I know some of you complain about this, but it makes it far easier to see what corresponds to what. So we start with your mean of 52 and your standard deviation of 15. Okay? All right, so find the weight that corresponds to a z-score of negative 2.33. Give me an estimate of what this x value should be. 18? Okay, 18 works for me. 18, anybody else have an estimate?
19.
Okay, so let's see what we get. We take the mean plus the standard deviation, this is what's forcing us to subtract, the z-score, times the standard deviation. Put it in, and what did you get? 17.05. So close, pretty darn close at his 18, right? That was pretty close there. Because negative 2.33 falls over here, between the negative 2 and the negative 3. That's why you use a sketch. So when my z-score is 3.10, 3.10 is a little bit more than 97, right? So I say x is equal to 52 plus 3.10 times 15, and what's my x value? 98.5? 98.5. And when my z-score is 0.58, I am somewhere in here between 52 and 67. Maybe like 61, 62. 60.7? Sounds good to me. 52 plus 0.58 times 15. Okay? Are we feeling these?
Yes.
All right. So tomorrow, we're going to take one more step, and instead of giving you the z-score, we'll probably give you a percentile. I want to be in the 20th percentile, in the 90th percentile. And then we'll do the whole 9 yards.